let's start recording again. Okay, so we're back to just plain and simple finding reference angles. That's easy, whatever. So before we actually jump into that, remind me what the scroll, come on, you can do it. There we go. So this is 0 in radians. What's straight up in radians? Well, 90, but what's pi over 2. There we go. And what's 180? Pi. And down here? 3 pi over 2. So if I've got 7 pi over 6, which was what was in the problem, 7 over 6 is between where? Yeah, say on quadrant 3. This is like 1 1/6. So, boop. 7 pi over 6. So my reference angle is going to be this guy. So 7 pi over 6 minus from here to here is pi, which is 6 pi over 6 is pi over 6. Boom. Dude, that was as easy as pi over 6. You may have grown, Cade, but you still laughed. Is that happy, Angel? No, I'm not going to do if you're happy and you know it again.
Oh, I see. I'm like sitting here looking for where you
Oh, yeah. Yeah, so by the way, this was originally just pi, but then to subtract the fractions, I changed it to 6 pi over 6. Okay, cool. Let's jump a couple questions, because that one was easy. Let's go to 17. Oh, okay, that's actually even easier because it's in degrees. So, reference angle for 1105 degrees. Oh, it's easy. So 1 time around is 360, 2 times around 720. Then, yeah, but you would have to get the remainder and multiply by 360 again. So 3 times around is 1080. So let's take that off first.
He always knows what's best.
Well, that's what we had to do.
Scoot. Screen, scoot. There we go.
You didn't get this far in pre-cal.
You didn't get this far in pre-cal? What did you do in pre-cal?
We did the basics all year long because nobody could get the
Wow.
basics down.
Same. We did the basics, and then for like second semester, we would always have potlucks.
Potlucks?
Yeah.
Like,
And we had like morning class too. We were bringing pizza and stuff. She gave up.
okay. All right.
Oh, shit.
1, 2.
Yeah.
And that's 25. So this one's kind of silly because after we took off the 360s, we got 25, which is going to be the reference angle. I mean, if we had ended like over here or something, then we'd also have to find, okay, what's that? But since we ended right here anyway, it's like, oh, it's just that angle right there. By the way, I don't know if they're going to use this word or not, but before we do like take off the full rotations, this is actually also not just a reference angle. It's called coterminal.
Oh, I know.
Hey. Terminal.
I think we
Angle.
talked about it.
Yeah. Okay. I can't remember. If it didn't happen in the last like 30 seconds, I don't remember it. So, which is why I always tell y'all, if you ask me to do something and I say yes, you still have to email me because the conversation goes away as soon as you like walk. So, all right. So Yeah, if they actually stop in exactly the same spot, then that's called coterminal, which is what it sounds like. So that would be 25 degrees. Really?
No, you love it. Who did I say that to?
Unless I did my arithmetic wrong. Oh, wow. Okay. So we'll do one more. Okay, so 37 pi over 6. Well, that's 37 over 6 is like what? Like as a mixed number. Yeah, 37 pi over 6. Well, actually, that's 36 would be 6 pi, and then plus pi over 6. Right. 6 pi is 3 full rotations, and then you've got pi over 6 left. So it's basically the same picture, except there's pi over 6. 1, 2, 3. And again, it's silly because that's the reference angle. Yeah, that's coterminal as well. So
we find the remainder, and that remainder is.
well, it is because those two angles happen to stop in quadrant 1. Again, if this angle came over here and stopped like that, then the remainder would be that guy, but the reference angle is this guy. But we happen to get ones that stopped like just past the thing. So, okay. There we go. Enter. Cool. So is everybody happy with referring angles? Let's go down to about 25, sure. I was going to go 23, but I think you're right, Angel. We should go 25. Use reference angles to find the exact value of the expression. Do not use a calculator. I don't know if they can really stop you, but you should be able to do this without a calculator anyway. Cotangent 29 pi over 6. So 29 over 6 is, 4 pi, and then 5 pi over 6. Okay. So 4 pi just means we go around twice because 2 pi is once. The 5 pi over 6, where is that? Yeah, so here's pi over 2. Here's pi. 5, 6 is somewhere between a half and that. So that would be 5 pi over 6. Okay. So my reference angle is going to be this little guy. So pi minus 5 pi over 6 is pi over 6. So the reference angle is pi over 6. Well, it's still positive. When we do cotangent, we're getting a negative because slope is negative. But as far as the reference angle itself, we just say pi over 6. So is everybody happy with how we got pi over 6? Angel didn't seem to be happy for a second. You got it? Okay. So cotangent, well, it's just going to be cotangent of pi over 6, which according to our chart, well, this is 1 over tangent pi over 6. What does our chart say tangent pi over 6 is?
One over root 3.
1 over root 3. So 1 over root 3 is root 3. So the cotangent of 29 pi over 6 is going to be root 3, but it might be positive, might be negative. And again, to figure it out, you look at the picture. Tangent is slope. That slope is positive or negative. Yeah, that's a negative slope. So it should be negative root 3. There we go. Square root 3. Cool. Let's do one more like that. That one's the same daggum problem. Not quite, but just nearly. That one's just silly. Oh no, that one's not even a word problem. It says, oh, you stop there at 15 pi over 17 and negative 8 pi over 17. And this is, well, you can tell by the fact it's got 1 and 0 here. The radius is 1. So this is the unit circle. So sine, if you're on the unit circle, you don't even have to do the divide by r. Sine is just going to be equal to which coordinate? Y. So 17. Y is the loneliest number?
There's not a part spot line. I don't remember.
No, it's,
What's tangent going to be?
that's both of them.
Yes. Which one is divided by which one? Yeah, it's sine over cosine, which would be y over x. So 8 over 15, because the 17s cancel. It's nice. The denominators cancel a lot. And then the rest of them are just 1 over those. So cosecant 1 over sine. Sine is y, so that's negative 17 over 8. Secant 1 over cosine, so that's the 17 over 15. And cotangent's 1 over tangent, so that would be the x over the y, which it would be 15 over 8. Is that happy? Okay, I think that's probably about enough for a day, don't you?